at another existence theorem, which is the mean value theorem. The mean value theorem is really just a more generic version of Rolle's theorem. Another way to say that is Rolle's is a specific instance of the mean value theorem. What do I mean? Okay, well, let's look at the theorem. So the mean value theorem says that if f is continuous on the closed interval AB and differentiable on the open interval AB, so that's how Rolle's theorem started, then there is a value c in the open interval AB such that f prime of c equals f of b minus f of a over b minus a. What's this? Well, again, that is slope. And what does f prime of c represent? That represents the slope at some point c. So all this is saying is that, this is my point A, this is my point B. If I was to find the line between those 2 points, so like that if these requirements are met, there has to be some other line within that interval that will have the same slope. Look at that. That's actually pretty good. Those look pretty parallel to me. But that is what the mean value theorem is telling us. So again, that's what I mean. This is a more generic version of Rolle's theorem, because Rolle's theorem is telling us this exact same thing, but only when the slope is 0, right? So this is now the mean value theorem is saying, well, this is actually true for no matter what the slope is. So let's do an example. So find all the values of c in the open interval AB such that f prime of c is f of b minus f of a over b minus a. So here's our interval. And so we want to find values of c that will make this true. First, we need to actually make sure, okay, are we meeting our requirements of the mean value theorem? So if I think about this function, f of x equals x plus 1 over x, what is the domain of that function? Well, the domain is negative infinity to 0 and 0 to infinity. However, I'm looking on the interval 1/2 to 2. So on the interval from 1/2 to 2, this function is continuous and differentiable everywhere. But on its entire domain, it is not. So that's one thing I would want to check for first. Okay, so it does meet my requirements though, because again, what I'm looking for is the function continuous on the closed interval and differentiable on the open interval. And yes, it is. Okay, so now first let's figure out, okay, what is f of 1/2? So I'm just finding the slope. So f of 1/2 is going to equal 3, and f of 2 is going to equal 3 over 2. So now let's actually find what is the slope. So f of 2 minus f of 1/2 over 2 minus 1/2, and that is going to equal -1. What I just did there is 3/2 minus 3 over 2 minus 1/2. So I get -1. Okay, now I also need to do the derivative. F prime x equals bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Let's simplify that a little bit. That'll become x minus 1 over x squared. So f prime of x equals -1 over x squared. Okay, so I found the derivative, and I know what slope I want. So now what do I do? Well, what does the derivative represent? It represents slope. Yes. So what do? Well, we take the derivative and we set it equal to the slope that we want it to equal. And then we can solve for x to find the value where it equals that slope. All right, that makes sense. So we're going to say -1 equals -1 over x squared. a little bit of solving, and I'm going to end up with x squared equals 1, so x equals plus or minus 1. But remember, we were only looking on the interval 1/2 to 2, so the minus 1 doesn't really help us. So we get x equals 1. So our c value on the interval of 1/2 to 2, where f prime of c equals f of b minus f of a over b minus a, is at 1. Right. Again, Rolle's theorem is an existence theorem. It's common sense. The mean value theorem is another existence theorem. It's a more general version of Rolle's theorem, also common sense.